Hey gang, Wall Bill here. Today we're going to show you how to save thousands of dollars this summer, or any summer for that matter, that your air conditioning system should go on the blink. We've got one of the easiest and least expensive fixes. Now this doesn't work all the time, but this is the first thing that you want to check, and that's the capacitor, the start capacitor. Sometimes your compressor will not run, but your fan will, and that happened in my case here this week. And the air conditioner wasn't putting out any cold air. I came down to the compressor unit, and it wasn't putting out any hot air. And when they're not putting out any hot air, and it's like 90 degrees outside, and the fan is blowing on your outside unit, that you know that the compressor is not running. The simplest thing is the capacitor, simplest and least expensive, and then you go all the way to the most expensive thing, and that's when the compressor is on the blink and will not ever run again, and then you have to replace the whole unit, and that's when it costs thousands of dollars. But anyhow, that's what we're going to be looking at today, is the capacitor. Turned out that was what my problem was, and I thought I'd make a video and show you all about it. Again, we want to thank all the veterans that are listening to our videos, along with everyone else, of course. But if you know a vet, thank a vet. And here we're going to look at this old unit here. This is a Train XE800. If you can believe it, these condos were built back in 1987, so that puts this thing at 31 years old, and up until today was putting out lots and lots of cold air. One thing you can do is make sure that the top of your compressor unit is always clean and clear of any debris, and that the side vents there that you can see all the way around it, clean and clear of any debris, and without, you don't want a bunch of plants growing around it and stuff like that, because that all keeps the air from going through. You can hold your hand on top of this grate when this fan is on and feel all kinds of warm air, at least 80 degrees coming off of this thing. And when it's doing that, you know that it's pulling all that warm air out of your house. When I felt this thing today, the fan was on, it was blowing out just the ambient air temperature that we had outside. So it definitely, the first thing I'm going to try is the capacitor, because people have spent thousands and thousands of dollars on units that, replacing their units when they were probably just fine. All they needed was a capacitor. And capacitors can cost anywhere from $15 that I paid for mine, all the way up to as high as $50, which I've seen, and that's highway robbery. But you should be able to pick up a capacitor for these things. It's usually a 35 microfarad capacitor. I'll show you it later. For anywhere from $15 to $25. And for that small amount of money, you can get this thing up and running again most of the time. I'm not saying all the time, because if the compressor is shot, then you have to replace the whole thing. But so many times people have spent thousands of dollars for an entire new unit when all they needed was that $25 or $15 run capacitor or start capacitor. So anyhow, we're going to get into taking this thing apart. I'm going to go along and I'm going to remove all these screws and show you how to get it apart. So the first thing we're going to do is we're going to take the screws out of the top, and the easiest way to do that, of course, is with a drill driver, because you get at least 8 screws that are holding this thing together, or at least the top. makes it nice and easy. You can do it with just a regular 5/16. Usually they're something like 5/16. Might be quarter. These are 5/16. And this will take the top off. And this is the fan and everything. By the way, first thing I should have told you is we want to, I'm going to make sure that the camera is aiming towards it here. We want to make sure that we disconnect the electrical circuit. Sorry I was late on that. But on this one, it has just a 4-prong pull device like this. Some of them some of them have the big 220 fuses in them, because this is 220 volts. Be very careful, and that's the reason why we're pulling it to begin with. And some of them will have a breaker switch on it. So whichever yours has, make sure you turn it off. So now we want to lift the lid off, and this has the fan attached to it. So we want to lift it off, and this one just doesn't have long enough cords that we can set it down. So I'm just going to set it aside so that I can show you what else we have to do here. And when you're doing this, you want to make sure that you don't bend the blades of the fan. That's very important. We'll sooner or later figure out a way to get it on here. So now that we've got the fan out of the way, you can look down in here, and this is your electrical component section. This one happens to have 2 different capacitors. This one has the run capacitor for the this is for the unit, the compressor. This is the start capacitor for the fan. Some of them have, well, you can see this one has 3 prongs. It is made to run the fan. One of these prong areas over here is for the fan. So some units, some compressors have the wires all going to the same capacitor. This one happens to have 2. And these things are so cheap, I would highly suggest when you buy one to buy 2 like I did, so that you can have one as a spare in case it goes out in the middle of the summer again when it's hot weather like it was for us, and I wouldn't have had to run off and find one. I could have just replaced it within a few minutes and had it up and running again. So that's your capacitor. That's what we're going to be removing today. There's 2 wires on this one because it's strictly for the compressor. You get the 1 wire over there, which goes, this one here goes to the compressor, and then this is the charging wire that comes from your electrical side, and that charges the capacitor. Now before we go messing around with this, you want to take a screwdriver and go across those 2 leads there. Now we've got, as you know, we've pulled the breaker, and so we've got no electricity running to it, but these things can have a charge on them, and you could get shocked from it. To make this a whole lot easier to get into, there are a few other little screws that you can take out, screws, bolts, whatever you want to call them, self-tappers. There's one there, and down the corner here is some other ones, right there, and right there, and then there's even a couple over here that, if I can get them to show you here, there's one here and one here. So you can, if you happen to have this same unit, you can take those off, and this whole thing will come apart here on the side, and you'll be able to manipulate this around to get the capacitor out. Because the capacitor is, I've got this one loose since I've already changed it. The capacitor is has a clamp in there that's holding it. There's one of the screws right there that you can see, and there's another one over on this side, a little bit harder to get to. So in order to get to those screws to loosen that clamp up, you're going to have to probably remove this triangular shaped area off of here, and then you can get to those screws and get that loose. And what I did is I just left it loose because it's not going to be moving around or anything like that. Not going to have to worry about it coming out of there, and that way if I ever have to change it again, it'll be much easier. So anyhow, I want to show you how to test out your capacitor. Now this is the old one that came out of it, and you have two different terminals on this one. This one has 3 terminals. Doesn't really matter. I'm going to show you how to test them out. So you take your trusty volt-ohm meter and you set it to ohms. I've got this one set to about 2,000 ohms. And anybody that has never used an ohm meter, when you touch the 2 prongs together on an ohm meter, whenever it is set to ohms, you're going to see that you get your reading changes there. See? Okay. Eventually it will go to 0. There you go. So that means that you get a direct short if it goes to 0 like that. Okay. So we're going to check these out, and you should get some sort of resistance here. You should get some sort of reading on there. Now we're going to put one prong here on this one prong on this one. You can see that the reading does not change on the volt-ohm-meter. That means this one is open. When it's open, it's shut. Okay, it's done. Now on this 3-pronged one, you have a common, which would have a C on it. You have one that says fan, F-A-N, on there, and you have one that says H-E-R-M. Now that is for your compressor. So we're going to go between the common and the H-E-R-M, and we should get a reading on here. Watch what happens. It'll go up and then it'll come down. See, it's going up and then down. That's a good capacitor. Alright? So we're getting a reading. Up and then down. There's my dog barking at somebody. Anyhow, and we're checking the other side, the fan side, and see, that one's going up and down. So that's what a good capacitor should do. That's showing that it's building up capacitance in there, building up electricity, and it's working. So that's how you test out your capacitor. And hopefully your capacitor will be open like this one, and when you replace it with one that tests out good and is good, your compressor is going to start right up again, and it's going to cool the house just like it always did. You'll be saving yourself several $1,000s, and it'll only cost you probably somewhere in the neighborhood of, like I said, this was $15, and in fact I bought 2 of them, like I said. So but I've seen them run all the way up to $50-some. But if you find that, only buy it if you absolutely need it, because you can find them for, down in the teens, and they do exactly the same thing. These are 35 microfarads usually, and the fan side is usually anywhere from 4 to 5 microfarads, either a 4 microfarad or a 5. And they're also, by the way, the compressor side is 440 volts. Maybe you can see this or not. And the fan side is 370 volts. So yeah, a little bit different voltage on there. But yeah, 440 on the compressor, 370 on the fan side, 35 microfarads on the compressor side, 5 microfarads on the fan side. And that's what you need to replace your capacitor and to get your compressor and AC up and running again. So we hope that we've saved you a lot of money, a lot of time. It's a simple process. Anyone can do it, especially if you listen to my video, and try to make it as easy as I can for you. Again, I want to thank all our veterans, and hope that you all will hit the like button, and that you'll come back and see some more videos on do-it-yourself tricks that'll help save you time and money. So it's Wild Bill signing off. You guys all take it easy. Have a nice day. Another little tip I'd like to show you to keep your compressor and air conditioner in top working order and putting out as much cold air for you as it can. The line going to and from the air conditioner especially the larger of the two, make sure that it is well insulated all the way to the wall. Best way to do that is with pipe insulation, the foam rubber type stuff that you can get at any hardware store or Lowe's or Home Depot or Menards, any of the other ones. It's real easy to use. You just wrap it around. Some of it has its own sticky stuff on the side, so you can stick it together, or you can put tape along the seam, and then I like to wrap it, as you can see, every 6 inches or so. I did try to use electrical tape at one time. It has a tendency to stay on for a few years, but it does come off after, maybe 3 or 4 years. This that I've used on this one is just duct tape that you can either cut it in thin strips, or this was a thin roll of duct tape. But that will keep your compressor working at its optimum, because you're not losing any of that cold fluid going upstairs by heating it out here. Okay, if this pipe were exposed, it would be exposed to the outside air, and you'd be losing a lot of efficiency. So that's a good thing to do on your air conditioner. I keep thinking of other things to tell you. One thing to make sure is do not wrap the small tube together with the big tube. Okay, you can leave the small tube out like you can see this one is, but don't put that small tube down on top of the bigger tube and then wrap them both, because then you're cooling the one and heating the other, and that's not what you want to do. Okay, so the larger tube is the one that carries the cold fluid, and so you want to keep that as cold as possible by wrapping it up. The small tube, you can see, is on top there. It's not wrapped with the larger one.